Hi everyone. I wanted to make a quick video for the lab report that you're writing up for BIN521L proteomics and protein biochemistry. In our lab, we worked with mass spec data, and we have a lot of these very simple text files that really are just two columns of data. We have the M over Z values and the intensity that was measured on the instrument in millivolts. And so there's a lot of different ways that you can display this data in your lab report. And I gave you, as part of the lab report description, some example figures, and I thought it might be helpful to see what code I used to generate those figures and why I made those choices, and also give you some ideas of some other tools that you might want to use, some other packages, some other settings with your ggplot to be able to make something that looks even better for your lab report. So I kind of thought of my examples as not being like the key example, right? This isn't like where you want your picture to be, but you want, they're kind of like the ugly plots that can be like, okay, this is the basics. Like, this is the information that I want you to have, but think about how with themes and with other settings, you can make something that's a little bit more what you would expect for a publication quality figure. So the first thing that you have to make a figure of is the bovine serum albumin peaks for the non-digested protein. So here we expect to see about 3 peaks, and they're not quite in the perfect spots. They're not really exactly where they need to be because our calibration file was not high quality. I went back the week after lab and I actually reran some of the spots. And I think the real issue is the actual peptides in the TOF mix were pretty degraded. And so we didn't have a good quality sample for our time of flight mix, which meant that our peaks weren't where they were supposed to be for calibration. But you can see when you use the G2 file that we're pretty close. And so you're going to see the 3 peaks for M over Z ratio around 66 kilodaltons, 33 kilodaltons, and 22 kilodaltons. And those represent the +1 charge, the +2 charge, and the +3 charge for the intact protein. So when we read in the file, the first thing I always do after I read in a file is look at it and just see like how it came in. Did it expect headers when there weren't headers, or vice versa? And I can see that everything here is pretty clean. The one thing I might change is maybe use either a names command to give the columns a little bit better formatted names, or use something like grepl, or actually just like a replace function to go through and remove all of those periods that are there instead of white space. It's really up to you what you think is easier. We maybe don't even want to keep all of these columns. The only ones we really care about are column 1 and column 2, right? So what's the M over Z ratio in Daltons? What's the intensity in millivolts? So I also want to think about the range of data that I want to keep. And I'm going to comment out this to start so that you can see what the plot looks like if we look at the entire range of data that was recorded, and then we'll cut it down to only look at the rows for the data for the region of interest. So I run the library command just to make sure that ggplot command is available. And then when I graph it, I can see that I'm getting the 3 peaks I expect around 66, 33, and 22,000. But I'm also getting a small peak down here at around 18,000 and getting this peak up here at 69,000. So those are 2 areas that are not part of the window that we want to look at to consider the entire protein. So what can I do to minimize that? Well, the easiest thing I can do is subset the data to the region that I want to look at where the 3 peaks are expected. And once I do that, now I only have 3 peaks. I can look at the zoomed in version of the graph and I can see not only do I have the 3 peaks marked, and I did this by having both geome path to trace each of the data points that's recorded in the file, but also geome point to show you where actual measurements were taken. And now I could, convert this into a math file, but it's just really easy to see how these three are related to each other. In addition to the settings that I have here, in order to have a plot that would be like appropriate for a lab report, I think the big things that need to be changed are cleaning up the X and Y axis titles and adding a plot title. So have some description of the sample in this experiment. That could be something like, undigested bovine serum albumin. It could be even like include the catalog number and like the catalog description. I don't really think that's necessary, but just something to let the person who's reading your report know where this sample came from. And then, you might want to consider playing with some of the formatting. Do you want the text to be this big? Do you want maybe all of the text in the figure, including the labels on the graph, the axes titles, and the axes marks? Do you want all of those to be the same font? Just those kind of little things can make it look much, much cleaner. And then the last thing I would recommend looking at is themes. Um, one of the big things that can help a graph go from looking like an example in our cookbook to looking like a plot that you would actually put into a research article is just removing that gray background, right? That gray background, it isn't always the thing that makes it look nice. Nicest for like an actual publication. You often want a white background or some other background, and so themes are a good way to switch out that look. So that's it for how to make the first plot. I'm going to make another video for the other plots that you want to provide in your lab report.